We're continuing the Act 3 challenges, and this is On the Wire, a challenge that is on paper 4 snowflakes out of 5, but in reality you will see that it's closer to a 2 snowflake challenge. Let me show you how I solved it. So this challenge is a hardware related challenge. Some hardware protocols will be part of the challenge, one-wire and SPI and I2C. So these are very, very common protocols in hardware devices. You will probably see something similar even on like more higher end consumer devices, not just embedded devices. So you see this even in case of laptops, for example. Some of the components on your motherboard might communicate with these protocols. And the challenge is hosted by Evan, who's next to the City Hall. And you really should talk to Evan about the challenge and get the hints. So I'm here, I am talking to Evan, who's introducing himself, and then, okay, so actually the conversation is not that important apparently. I thought that they had some details in the conversation, but the hints are, I sort of kind of feel like that they are intentionally this detailed, but I'm surprised then why is this a 4 snowflake challenge. So get this. You get the first hint, and this is the hint that you're getting. That's just for the first one. Very nicely structured hint, talking about the wire names, how they're going to give you an indication which protocol we're talking about. And then it mentions that some protocols are LSB, some protocols are MSB, then some of the details on these protocols, and that's just the first hint. Okay, now we can move on and get the second hint. More very, very detailed stuff on the clock and data signals, specifically for one-wire, SPI and I2C, technical aspects, folding and rising edge, all of those just handed over to you as you like just getting the hints. We're already 3 hints in, and then some critical details, byte or bit ordering of the protocols. Is it MSB first or LSB first? Like one-wire is LSB first, SPI and ICT is MSB first. So you get all these details, even converting the bytes. And then there's a twist in the challenge that the first messages on, I think it's one-wire if I remember correctly, those are in plain text, and then the rest of the messages are going to be XORed. But we don't even need to think about that, because the next hint is giving you a full function on decrypting the XOR, which is, yeah, sure, it's not super difficult, but, and again, like very, very detailed description. So when I saw this, I'm like, wow, I don't know how much coding is required here, but this is almost like, you know, like a full prompt, a very, very detailed prompt for an LLM tool. This kind of prompt is excellent for an LLM tool because it's structured. And the last bit, and this is going to be the only manual part that we will do here, is talking about how the WebSocket communication is structured. So we are going to get the signals as WebSockets, communication messages, and we just have to load it in as JSON objects basically to our script that will then decode the protocol messages. And well, you can, I guess, write those scripts and programs, but you know what is really, really good and writing simple scripts and programs, and it's probably going to be way faster than you are. Yes, all those LLM tools out there. So not even for a second I was thinking of writing these actually. Okay, the number of hints is stopping at 5, so we have altogether 5 super detailed hints here. And when you click on the little robot here on the wire, it will start socket communication. So you can see that you can select the protocols. Now these come in stages. So, and this is in the hints actually. Once you unlock the first stage here with one wire and decrypt the message, you can move on to the next one and then to the next one. And if you look at the network communication, and look at the that's WebSocket, right? So you look at the WebSocket communication, you can see that this first one is DQ. I'm not really sure why we're not seeing the entirety of the messages. Okay, give me the full thing. I find this one very confusing with a WebSocket communication, by the way. So I was poking around just a little. And then here, again, I don't know, it's very, very frustrating. So later you can see that we have the MOSI and SEK for SPI. So this is a clock signal, and we have a data line here. And then we also have the SCL and SDA signals, similarly clock and data for the I2C protocol. Now the best way to capture it, in my opinion, is definitely not the browser tools. And I'm even going to leave behind this whole browser here and move on to my other browser with my other account that has the traffic captured by Burp Suite. Make sure that we have all the messages here. I don't really need to capture anything here, but I just like to have a nice clean state here. And there is the game WebSocket communication here on socket ID 1. We can totally ignore this one. It's not part of the challenge. I actually recommend clearing the history. And so the only annoying part with Burp is there is no export functionality that I'm aware of to natively take these and capture it. I guess maybe in the logs. Not sure. Can we actually do that on the logging level? I'm not sure. I don't think so. Maybe under logger there is something. Anyways, so I couldn't really find anything that is natively available, but I was like, well, let's go and check out the extensions. So if you search for socket, and strangely, if you try WebSocket, you're not going to find all the. Oh no, I actually do. Huh? Cool. Weird. I think I tried this with WebSpace socket, and that one only. Yeah, I'm not going to find that. Okay. So I found 3 extensions. One of them promises that there's an export. I think it mentioned somewhere. WebSocket history, auto repeat, match and replace. Okay, apparently I cannot read. So this one from Sync is a really nice one when you just want to analyze it, but I need to export the messages. And this one promises export to CSV. Not my favorite kind of format. This one proven to be the most nimble one of all. It's a very, very simple extension, but this worked well because you can directly export to JSON, well, also XML, which is blah. But the other one, monitor and exporter, which is very important. Maybe just search for exporter and you will find the one. So these two are excellent. I use this one simply because there's one less layer that I need to, get rid of. Well, it's not like I'm going to code anything here, as I mentioned, but still, you get the idea. So we're going to clear this history, and I'm just going to show it once how it works. And then I have files ready with my captures. We're just going to use those captures because this is just really a manual, mundane process of capturing the data. So what we need to do is take our browser here, which is hooked up on the capture proxy, your attack proxy, and then you open the application. And I actually recommend closing down the other tab for that time while you're doing the capture. so we don't capture accidentally like unnecessary amount of messages. And you only need a couple of seconds. So I don't know if you can see the slider here. It comes in bursts, and you can just very quickly close this one, and this should be already enough. Now you need to do some cleaning, or well, just have the LLM like basically do the cleanup for you, so you don't really need to mess around. I thought that, you know, cleaning up this might be a good idea. So cumbersome. So you can filter on the URL, and you can see that we have a vir/dq for the name of the socket, which is the same name as you have in the hints for the various vir names. You can also order by WebSocket ID. So we had ID 1 for our game communication socket, and I can just delete the selected items, and the rest is the actual socket communication. If you look at an order by messages, you see that we see a connection message here, and then we have a marker for being idle on the line, reset, presence, and then the transmission starts. And we have T for the time and V for the value, or well, voltage, I guess. So we have high and low. This is like basically looking at the vir with a logic analyzer. And yeah, that's all. That's all we need to do. So if you go to any of the extensions, this one will be empty, and this is what we're going to use, but we need to go and select all, and then we can do extensions, WebSocket history exporter, and then send it to VSX. You can also send this one to the traffic monitor and exporter, but that's not necessary for that extension. So we're just sending it, and for some reason this pops up in a different screen, and you can see that this many messages were added. If we go to the exporter, we can see these messages, and we can quickly just select JSON, select the file, and export messages, and it's going to be in JSON format. For the other extensions, you can just select the channels like so, and then export to CSV. This is probably the most convenient one. So this is WebSocket. What was the name of the extension again? This is the other one, Traffic Monitor and Exporter. This is also a phenomenal, very, very nice and convenient exporter tool, but it exports to CSV. Now inside the CSV, you will still have the JSON, so it's just like weird. So they're going to have this kind of like CSV output here for the direction, binary, and timestamp. And then the messages are still going to be in JSON. So it's just an extra step that you need to parse the CSV for the message column. And I was like, nah, I don't want to do that because I was still considering writing the script. But yeah, it wouldn't make any difference. So these two are great options. Unfortunately here for Socket Sleuth, I don't see any means to do the export. You cannot like mass select or anything like that, but yeah. And the other tabs are not doing anything either, so there's no like export functionality, but this is great still for, you know, exploring stuff. But I would probably go now with this one because it doesn't require me to do any manual filtering, but you get the idea. So basically it's, yeah, a different type of export. Now instead I use the other one, and this is what you end up with. Again, I think it's potato. This is just, you know, JSON, and you can directly parse this file. You don't have to deal with this, but you can see that the messages are still going to be a nested JSON object here. And that's where you should stop doing any manual work and go to your favorite LLM tool. What I did, I fired up Claude and I did something nasty. So you can see that even being a bit snarky about it and say another day, another CTF game challenge. I'm going to copy and paste here, change description and the hints, and this is what I did. So I did a big paste here, and basically I just formatted a bit the hints, not too much, like basically just to match the same like level of formatting and detail, and then also the description of the challenge. And then I took my WebSocket wire DQ JSON export, dropped that one too there, and I told like, hey, this is the WebSocket, and give me a solution. Basically, that was it. Then I would go through and figure out that T was for the timestamp, V was for the signal value, 0 or 1. Also discovered that there are markers, then explains that the wire protocol is basically depends on like how do we like pull down the signal, how long we pull down. It's going to represent a low or a short pulls for 1 bit and longer for zeros. This is how one wire works. And then also discovers that there is the first character, which is CC, which is something called skip ROM. I had no idea what that was, but quite frankly, I don't even have to understand that. So skipping it and writing this out as the output. This is on a first go, perfect script. I'm going to include this one as a paste to solve the first stage of the challenge. Even going to show me the output here, that we now have an XOR key for the next stage. That's it. So I can also demonstrate how well it works without thinking. There we go. I have to place the name of the export that I did, the manual export, with the same exact name that I pasted in. So I don't think it like smart figures that one out. Yeah, there's one line you need to modify. So this one I just did /. Okay, because this is user data upload. So this is some Claude AI stuff. So, okay, I was lying. There is not one flawless script here. You need to modify this and replace that part with a dot. I'm going to upload the script that does that. Or you can just, tell the LLM tool to have a parameter for the file name. I was like, this probably works flawlessly because it already got the solution. So I'm just going to modify the script a bit. So you need to have the export with this file name. And here's the output. Here's the key. I mean, it's almost like Lukma, no hands. Amazing. Absolutely amazing. So these LLM tools are now at a stage where we really don't have to mess around anymore with these simple, like, what is it, 200 line scripts. And otherwise it would have taken me probably a couple hours to, well, and an hour at least, for sure. Probably not hours, but this is complex enough that I probably would have messed around for like an hour to have everything. And instead I got the results in a matter of seconds. All right, so the next step is then to capture more data. You can go back and switch from the, actually probably I should have done it in a different way. Let me just show you the first part of the whole thing. I'm gonna clear the history. We're gonna open back up. And I'm going to switch to the SPI one. I'm going to wait around a bit here, and you can see that we have a DQ starting up, DQ wire appearing here, but later we actually managed to switch. So I'm going to again close this browser tab. And I think I was fast enough so that we only have one message on the DQ wire, and the rest is the socket communication. Is this ordered by messages? Okay, it looks kind of weird. Like, why do we have everything quickly bursting as a data? Let me see if we have something similar here as well. Wait, I think I accidentally switched on the I2C one instead. Did I do I2C? I think we did I2C. Okay, let me try it again. because these are even wrong wire names, I think. So we want the SPI connected. We're going to wait for some of these bursts. This is actually a graphical representation of the bursts here. Okay, so some DQ signals were making their way in. Okay, so maybe I'm mixing up and SDA SLC is okay. So SPI is SEK and MOSI. So this is correct. It's just the initial burst of the data. Now this looks much better. So we see clock and data kind of mixed here. Okay, so this is probably good. And we can, filter this one out the same way. We can order by, socket ID, for example. Socket 7, we don't need it. So we can just go and delete the selected ones. Get to the bottom where, we don't have this unnecessary set of messages mixing in with the rest of the messages. And just, delete the whole thing. And then we have some clear signals here. I think you get the idea. So we can just, see, go to the top, delete selected. And then we can just do the same thing. And you probably want to clear this one first. Clear list. Go to the proxy, select all. And then send it. Get the message that it was sent, and then you can just do another export. Or here, you can go and select the... Now I realize why I went with the other one. So here you can see that we have two separate channels, and you need to grab those two. So here it would have been like opening two files and parsing two files because we have two lines here. Still, it's not the end of the world, but I think this is more convenient. So again, we have the file here, and then I just continued like, okay, here's my export for the SPI. Write me a script to solve this one too. And then, interestingly, so SPI is between the master and the slave. So we only have two components on an SPI communication line. And the clock signal will tell the other side when data is being sent, but we don't actually need that part. And if you look at the SPI decode script that it came up with, it just extracts the MOSI bits. So here in the other tool export, you don't actually need the SEK clock line. You can just go with one single one. With I2C, you're actually going to need both, but here you can get away with just extracting one of them. Because we don't really care about the clock. Whenever we see data, we're just going to go and parse it out. And this one already requires to use the XOR decrypt, which we got, and the rest is, the same kind of like conversion and just printing out a bunch of stuff. But the actual like parsing of the data is very similar, so we just need to parse the socket messages. And it's explaining here all the stuff using the IC, and then we get the next set of message. Read and decrypt I2C bus using the XOR Bonanza, okay? And we also got the decode SPI here. Again, this is not a flawless script because it has the actual uploaded data hard-coded, but again, just replace this part here with a dot, and that's it. So it's going to very nicely give you the message, and even just like information that it extracted. So like amazing. Again, one more time, super amazing stuff here. And then you have to do the next signal capture as well. I'm not going to show that one. I think you kind of get the idea. So it's just switching to I2C here and then capturing all the data. And it's going to end up in the channels SLC and SDA for clock and data respectively. either you export it here, the two files, or just one single file here. When you go to the proxy part, you can see that we also captured this one, and we can just send it the same way, and you should end up with something like this. And yes, you guys did. I was lazy solving this challenge and said like, okay, here's another set of stuff. Give me the solver. Oh, sorry, it's that was for SPI. No, that was for I2C. Oh, I made a mistake here and I forgot to attach the file. So it was like, I noticed you mentioned capture, but don't see an upload file. So I just did it again. I was like, oh, okay, whoops. And it got me this script over here, which again has the same shortcomings. So just replace this with a dot, replace the same file name, or change the file name if you have a different capture name. And it is very insightfully saw that there are some markers which will distinguish the address bit and the data bit and start and stop. So we don't actually really need to fully understand what's going on the data channel. We can just rely on the markers that are part of the communication here. So let's see. Yeah, so you can see there's a marker data bit here. So this is important and interesting. Marker sample and so on and so forth. So you can, there's also data bit here. So you can rely on the markers, but again, this is something that I didn't tell Claude to figure out. It just figured it out on its own. And then there are other devices here, but we don't care about those. So we just looked at the FreeC device here, and answer submit is the temperature, which is 32.84. I guess this is in Fahrenheit, because otherwise in Celsius this is not cold, but actually quite the opposite. It's too warm. It's already too hot, at least for me. And yeah, we have another script here, which spits out the result basically. There we go. So it gives us the end result, and we can just go back to our challenge here and submit this temperature value. And that solves the challenge. We can talk to Evan the usual way. So if you feel like that this was cheating, I understand that, but I think it is time for people who are involved in the CTF games, either creating the challenges or solving them, to realize that now we have a set of tools that makes any of the scripting and coding tasks very easy, and we can burn through these challenges lightning fast. If you thought that this was cheating, however, check out the next one, because it's also meant to be a coding challenge and try to understand some assembly. And well, I bypassed all of them again just by using an LLM tool. So if you're interested how I did it, just check out the next video.